Hi, welcome to this Open Security Summit session on February 2023. And here we're going to start looking at how to operate a secure Kubernetes platform. Cristian's going to take us through his wide experience in developing open source platforms that are secure on top of Kubernetes. So over to you.
Yes, thank you very much, Dennis, for having me, and thank you very much for the audience who prioritized this meeting over spending Valentine's with their significant others. So today I would like to talk to you about how to operate a secure Kubernetes platform. To get started, I am a senior cloud architect and elasticist and an adjunct lecturer at University of Sweden, and I'm passionate about cloud computing and information security. I'm the architect of Compliant Kubernetes, which is an open source CNCF certified Kubernetes distribution. It focuses on compliance with data protection regulations such as GDPR or Swedish healthcare. And at Elasticist, we operate Compliant Kubernetes for companies in health tech, ed tech, and fintech on over 5 cloud providers and on-prem. So today, I would like to start by talking about why we bother with Kubernetes at all. Let us remind ourselves what are the benefits that Kubernetes brings to justify its complexity. And hopefully that will build positive energy to discuss how to address the top challenges when operating a Kubernetes platform. And just to make sure that I'm not disappointing the security nerds out there, I'm afraid that these top 4 challenges are not going to be topics that are, in the range of security hardening your Kubernetes cluster around unknown unknowns. I plan to discuss that maybe at a future edition of the OpenSec Summit. Rather, these are what I would call basic security hygiene that is, let's say, kind of obvious and rather boring, but without getting this part right, you will definitely fail in security hardening your Kubernetes cluster. So just keep in mind proper expectations. We'll be talking here a lot more about security hygiene around Kubernetes than around the nitty-gritty technical details about how to security harden a Kubernetes cluster. So everybody knows that Kubernetes is an answer, but what was the question? And let us zoom out and look at the business context from 30,000 feet. Product owners are increasingly relying on lean thinking to discover application requirements by testing hypotheses out against the market. So you build a new feature, you measure its usage, and from that you learn what to build next. And in lean thinking, success not only depends on how well you execute of each individual step, but also how quickly you iterate over these steps. Now, of course, in the technical side, this is implemented with application containerization. If you're as old as me, then you probably still remember those times when you had applications were certified with works on my machine, and then the second you were trying to make that same application go through testing or through production, it wouldn't just work because you had a different version of Python or different version of Java or whatnot. So application containerization is proven to reduce friction when it comes to moving code from the development machine to production. And in briefly, it's a language neutral way to pack application together with all of its dependents. And now, sooner or later, you will want to run containers on several nodes, whether these nodes are virtual machines or servers. And you'll want to do this because you want to scale horizontally, since your application got so crazy successful that not even the biggest server is enough to deal with all of the traffic. You might also do this for the purpose of redundancy. It's 2023, society is very reliant on certain applications. A server failing can happen, but your application being taken down of it is no longer acceptable. And then another reason is simply to allocate the right nodes to the right containers, right? You might have databases that might benefit from very fast NVMe disks. You might have other analytics jobs or machine learning jobs that might benefit from GPUs and so on. So making sure that you're not throwing in the most expensive nodes and at the wrong containers and then just wasting resources. Now, once you have decided to run containers on several nodes, you'll realize that you have to tackle quite a few challenges, such as scheduling. On which node should which container run? Networking, how do I make these containers talk to one another and feel like they're part of the same cluster as opposed to them having to figure out how to talk across nodes? Service discovery, storage, self-healing. What do I do if one container fails or one node fails? I mean, I probably need to start those containers up again somewhere. And now there are very, very many solutions to these challenges. I have even read plenty of companies that were, doing it themselves and just having a featured platform team that was coding all of these things and solving them. And needless to say, they succeeded. However, in all this ocean of solutions, Kubernetes stands out because it is open source. And apparently many people like this because it means no licensing costs, but it's more than open source. It's also open governance. So no single vendor can derail a project. And this is something that many customers complained to me about. There was a certain wave of open source projects suddenly changing license to a less open source counterpart. And this was only possible because it was essentially governed by a single company who put their interest ahead of the interest of the project and the users. Now, Kubernetes is also very popular. It's adopted by many organizations, which means that it's more likely for you to find an ecosystem of users and administrators that can meet in the middle. It's extensible with custom resource definition, webhooks, and operators. It has a huge ecosystem around it, so it feels like if you want to add logging to it, that's fine. There is an application for that. You want to add intrusion detection, there is an application for that. You want to have something like API gateways, there is an application for that. And then for people like me who might be woken up at 2 a.m. in case our clusters go down or the application goes down, I really sleep better at night knowing that Kubernetes is battle tested and used in production by very many organizations out there. Now, just to make sure that I'm not confusing people, I'm going to use the word Kubernetes Platform quite often. And I kind of insist on this usage of this word because to me, Kubernetes is really just an engine, but you still need to build a core around it. And at the very least, you will have to add something like observability and security. And moreover, Kubernetes is additionally used to host additional services like databases and in-memory caches. So therefore, I'm mostly going to discuss Kubernetes-based platforms where Kubernetes is an essential building block, but by far not the only component to make the platform working. So that leads me to the Kubernetes Paradox. So Kubernetes has been launched in 2015, and ever since then, it has made tremendous technological progress. So it's nowadays so much easier to set up a Kubernetes cluster no matter what hardware is being thrown at you, right? So we had certain on-prem projects where pretty much, they just undusted some servers in the basement and had some load balancers. And guess what? We could use that to set up Kubernetes clusters thanks to projects such as Kubespray and Cluster API. It's also so this is, let's say, below Kubernetes, right? But it's also so much easier to build things on top of Kubernetes by, using various Helm charts and various operators for databases, message queues, and so on. Nevertheless, what I notice is that organizations are still struggling to operate a Kubernetes platform in a way that is truly secure. And in order to help you navigate this landscape, I'm going to share with you the 4 challenges that I have noticed that companies are having when they're embarking on the journey of operating a secure Kubernetes platform. And I'm hoping that, well, either you will have already crossed these challenges, or you will be given some actionable advice on how to cross them. So the 4 are setting the scope, fostering right alerting culture, doing disaster recovery training, and then fostering right maintenance habits. So let me start with setting the scope. And just to get in the mindset with this, let me start with an anecdote. So last summer, I spent holidays at my parents' place, and they actually had a book from 1911 called Engineering Handbook. And it was quite amazing that it contained absolutely everything that engineers had to know in 1911, right? It was 3,000 pages that contained everything from various steel profiles, like what's the difference between an H profile and I profile, how to mix concrete depending on what you want to do with it, how to calculate stresses when building a bridge, how to design an electric circuit, and it even went as far as to build your own car, right? And now, fortunately, engineering is kind of understood society-wise as, we need a bit more specialization in engineering, right? So I would honestly not want my civil engineer to tell me how to design a car and to make sure that it's safe. And just as well as I would definitely not go to an electrician to tell me how to mix concrete for my next home, right? Now, this sounds very obvious, and I'm sure you're all laughing about the absurdity of the comparison I'm coming with. But unfortunately, I get the feeling that this is exactly how we're treating software engineers. I mean, we're having this generic term called Devops, which, depending on who you're talking to, can encompass everything from, code for platform boilerplate. So something like, how do you handle a stick term handling properly? Or how do you do database schema migration? Or how do you handle rollbacks properly? All the way down to configuring switches and routers and storage cluster and safe disposition of hard drives to make sure that data is not getting lost. And unfortunately, I mean, the challenge with just having a large, opaque discipline called DevOps is that basically just too much knowledge out there in each single of these technologies to put them in a single head. And this is especially problematic if those heads not only don't have the luxury, as in some software engineering disciplines, to just Google quickly, like, how do I restore a Kubernetes cluster, but rather they need to be good at each and every one of these topics and troubleshoot things out of muscle memory when they're drowsy at 2 a.m.
And Cristian, just a quick one. And add to the mix that we also have a pattern of not really documenting everything. We have a pattern that the architecture is almost a design, right? So we moved away from having, in a way, detailed design specs, detailed sort of architecture diagrams to kind of putting things together, which works very well in some scenarios, but does increase the complexity. Also means that a lot of the knowledge is only on some people's head.
Oh yeah, don't even get me started on this. And some people misinterpret GitOps as we don't need to write documentation and we don't need a proper change management process because, hey, Git is going to magically take care of us, right? Yeah. So yes, I share your frustration. Exactly. So how do you set the scope properly? So I generally like to think about the tech stack as belonging to an application team, a platform team, or infrastructure team. And I have honestly seen so many ways to do scoping, right? In some cases, the platform team was higher up the stack and responsible for developing application boilerplate, let's call it like that, to deal with stuff such as SIG term handling or structured logging. But in other cases, the platform team was a lot lower and, for example, responsible for the storage cluster that integrates with Kubernetes. So the truth is that there are so many good ways to come up with a scoping that makes sense, as long as the scope is clear to everyone and as long as it assigns the right skills to the right task. So let me reiterate that scope is important because it avoids blame games. So things don't end up like, well, I thought that you should be having the Kubernetes cluster spread across multiple zones. Yes, but I thought that you should be then setting the correct anti-affinity constraints and things like that. On the other hand, it empowers the platform team to really make the choices that secure their platform because now they know which decisions fall under their authority. As I said, it assigns the right skills to the right task. And for those of you who are CISOs and have to explain yourself to auditors, auditors are apparently also pretty good at picking up if you're having too many people concentrated around the same things, right? So if you tell somebody like, hey, we have these two people, they're doing database administration and Kubernetes administration, and they're writing our front end, I heard auditors being extremely unhappy about that and flagging them. And finally, I think it really delivers very clear customer-supply relationships, right? So where the users are the customers of the application team, and then the platform team is the customer of the platform team, and then the platform team is the customer of the infrastructure team, right? And everybody knows, everybody can have like their mini customer success and their mini product management function inside these teams. So let me give you an example of a scope. We, for example, say that, well, within the scope of the Kubernetes platform is, of course, the Kubernetes cluster itself. All pods need to make Kubernetes cluster secure, observable, and stable, such as Fluentd, such as Prometheus, and whatnot. The continuous delivery tool itself, and then also additional managed services such as databases, message queues, and caches. And we also like to say what is not part of the Kubernetes platform. So, for example, application code and pods are not part of it. And the actual code that makes continuous delivery and continuous integration happening is, again, not part of the platform, and so on. That being said, while it's really important to come up with a clear scoping so as to make sure that your platform team isn't all around the place, you can't completely forget about things that are outside the scope either. So what we would recommend, for example, is to actually do a little bit of an application audit in order to help the application team to stick to best practices so as to make their application, secure and robust on top of Kubernetes. So we have talked quite a lot about these things, such as implementing safeguards to make sure that it's very difficult to use the latest tag, which is a pretty frequent mistake with Kubernetes and can lead to quite disastrous results, right? Or going through go-live checklist and actually, like putting the application team and a platform team in the same room and say like, okay, I'm going to pull the plug on one of your nodes. Can your application take this? And then just notice what happens and so on. And then we also like to conduct a sort of an infrastructure audit. And this sounds, again, very, very naive. But in one of our audits, for example, we discovered that the platform team was asked to keep the platform up 24/7, whereas the infrastructure team only offered 6/22. I wanted just to add to this point also, I recently read something called the Checklist Manifesto, which illustrated how checklists have made flights and also surgery a lot safer. And they were saying that, well, checklists are needed so that you get the dumb stuff out of the way so that your brain can focus on the smart stuff. And I would like to think in terms of this concept also when it comes to auditing things around the Kubernetes cluster. Let me get to the second topic where I noticed our companies are struggling when operating the Kubernetes cluster, which is alerting culture. So thanks to tools such as Prometheus and Alert Manager, setting up alerts is very easy. Unfortunately, alerting is hard. And the problem is really that, well, these alerts are only as useful as they are being given attention. So an alert is kind of by definition a signal from the platform team that says, I need human attention, I can't take it anymore. Unfortunately, what I noticed is that some companies don't foster the right alerting culture, which leads very quickly to a crying wolf problem or alert fatigue, right? That Kubernetes node keeps saying it's, or that Kubernetes pod keeps saying it's not ready, just ignore it, right? It's fine. And oh, that node, yes, every now and then that node will be not ready. Just ignore that alert, right? No issue. So why is alerting necessary? The way I like to explain it to CEOs is to avoid disappointed customers. Your CISO or your data protection officer will like to hear that, well, we need an incident management process and alerting is part of it. And your platform team will like to hear that, well, there are no unknown unknowns and that they gain confidence that, stuff just works, because if stuff doesn't work, we get clear and proper alert. So how do you foster the right alerting culture? Well, first of all, distinguish between P1, P2, and P3 alerts, have a clear alert workflow, and empower the team to tune alerts. And I'm going to talk about each one of these in the next slides. So P1 alerts, or needs attention immediately, I also like to call them 2 a.m. alerts, are mostly relevant for people who need to operate Kubernetes platforms out of office hours. And they should be really reserved just for events such as, downtime or data loss is imminent. Things like etc quorum has been lost, or disk space is full, or Postgres is suddenly having a split brain 2 primaries, which can very quickly lead to data loss and a lot of effort to recover it. And unfortunately, P1 alerts are needed, but try really to make sure in avoiding them. And you can do 2 things in order to avoid P1 alerts. first of all, invest in redundancy, right? So of course, it's a lot cheaper to have only one Kubernetes control plane node. But what I like to tell decision makers is that, well, you know, hardware is cheap. People leaving your company because they don't get proper sleep are super expensive, especially because in this industry, the skills are difficult to find. So run 3 control planes, have a minimum of 2 replicas for all of your deployment. Make sure that you use topology spread constraints so that not all of your pods end up on the same Kubernetes node, but rather are properly spread. Good news, this is going to be by default on Kubernetes 1.25. So if you haven't updated yet to it, here is another reason to motivate you to do that. And then as a bonus, do consider finding a cloud provider that has multiple zones, and you can spread the cluster across zones so that, you know, even if a whole data center fails, your application can still stay up. And then the other thing that you can do, so what redundancy will essentially do is that, well, Kubernetes node failed. Well, that's not something you need to react immediately on, right? You can wait for it. There is still sufficient redundancy for the application to be up, so that can be dealt with when the engineers are awake during the next business day. And then the other thing you can do is predictions. So in Prometheus, you have this nice function called predict linear, and you can write really complex queries that, for example, say, well, alert me if this will be full if in 3 days, right? And then 3 days is generally enough in order to bridge weekends and weekends with longer holidays and so on. Now, unfortunately, it will not be possible to always avoid P1 alerts, but the least you can do with them is to make them a bit less stressful by telling people exactly what they need to do in that case. And the way we like to present it is that you have like a nighttime workflow, which basically just says, okay, as quickly as possible, figure out if data confidentiality and downtime is at risk, and try either to fix the issue as quickly as possible, to silence the alert if it's just not relevant, or escalate it to your team manager because, I don't know, for example, imagine it's a data breach. You really don't want to leave engineers alone at 2 a.m. figure out what they have to do in that case. And then during the day, you can then take things a little bit more calmly, figure out what is the source of the alert, maybe write an incident report if it's something more serious, maybe think about loud, okay, how can we avoid this happening again, and so on. So then let us go on to P2 alerts, or needs attention within a business day. And, you know, they're still kind of annoying because they disrupt productivity. I'm actually in the same corridor with some of our people that are on the call. And, you know, now we're having only 1 alert every hour, so it's fine. But imagine getting these alerts every 15 minutes. It was really distracting, right? But nevertheless, the good thing about P2 alerts is that they do not ruin weekends, evenings, and especially not sleep. They can be taken slowly and calmly. And the nice thing is that, well, other team members also wait, right? So you might be pairing a more junior person with a more senior person to deal with the issue faster. And example of P2 alerts could be, well, Kubernetes node went down because you have sufficient redundancy. The persistent volume will be full within 3 days. The PostgreSQL primary failed and the secondary was promoted to primary, right? Again, take it calmly, no need to worry about this. The nightly backup failed, and so on. And then think about having also P3 alerts or review regular alerts. So things, for example, that, well, this pod, we had, for example, a Fluentd pod that kept being throttled, right? It meant that it had a certain CPU request, and every now and then, maybe once a week, it tried to go above that threshold. And it didn't feel like it was really actionable. The team was not ready to just allocate more resources to it, but it didn't really feel, it didn't really feel actionable. But after some time, we could see a pattern, and then we could act on it. So I often get the question like, well, how do I know if an alert should be P1, P2, or P3? And my advice is to engineer for change, not perfection. So in our case, for example, we made the Kubernetes platform over alert. It tries to send as many alerts as possible with as much metadata as possible around what the source of the alert, what cluster, what pod, what namespace, and so on. And then we use an on-call management tool such as OpsGenie or PagerDuty to prioritize and silence those alerts. And once you get the alerting culture going, honestly, I get the feeling that the technology is rather, quote, boring, right? So you can use pretty much things like Prometheus with this alert manager, Thanos to just set up all of this alerting, and there is a whole range of inspiration for PromQL queries and whatnot to get those alerts that you want to in your Kubernetes platform. So let me now go on to the other challenge that I saw companies facing: disaster recovery training. So there has been a huge wave on ransomware attacks, and it seems like companies kind of prefer to play the ransom instead of restoring from backups. And this definitely proves that, just saying we do backups is not enough. You need to know exactly that those backups, you need to be able to trust those backups, you need to know in how much time can you restore for backups, because otherwise your security posture is really weak. Now, as an analogy, think about how pilots are being trained, right? I mean, pilots are spending hours in a simulator every year to train things such as flaps not getting out anymore and engine failures. I mean, I have never had an incident in my life in a plane. Nevertheless, because these events are so rare, they are specifically trained so that in the unlikely event that they happen, the pilots already from muscle memory know exactly what needs to be done, right? And that's pretty much the case also with platform engineering. So it's highly unlikely that you need to do disaster recovery, but your team needs to know that, well, they can rely on the process and they know exactly the process to recover just in case. So why disaster recovery training? Well, incidents are really stressful, right? You're hearing your application team beep, beep, our application is down, can you please investigate, right? The clock is ticking. For some of the systems that we're having, disaster recovery is really complex and can be stressful. And then it's also kind of nice for the team to know that, no matter what happens, right? We lost etcd core room, we lost the Postgres database, the storage cluster is down. They really need to know that there's always a way out. Then another benefit is also that, well, you can measure the time it takes you to recover from the disaster to an operational state. And well, if I still didn't manage to convince you, let me just say it's mandated by various information security standards, and also by Swedish patient law, for example, requires you to regularly test your backups. Now, when thinking about disaster recovery, you have a few decision drivers to decide how exactly to do backup. So you have the GDPR right to be forgotten, which kind of says you should not just store data forever. And if you store backups for too long, you then add quite a lot of complexity in remembering to forget, not to restore things that you should have forgotten, right? On the other hand, if you also want to minimize the data loss, and then you also want to reduce the backup cost. And each of these decision drivers then push your latest backup, the latest backup you can restore from, the earliest backup you can restore from, and the distance between the earliest backup you can restore from and the disaster, right? So if you, for example, want a recovery point objective of, say, 24 hours, well, that means you need to back up nightly. If, on the other hand, you want a recovery point objective of, say, 6 hours, well, that means that you need to back up every 6 hours. If you want even lower recovery point objectives, such as 5 minutes, which is not quite common in Kubernetes clusters, but you might want to do it with a database cluster, then you might need to do with something like, streaming the WAL file or the segments that are written to the database to some location at a very frequent interval. And needless to say, this will increase your backup costs. Yeah, and like I said, the time between when a disaster is declared and the system is recovered is the recovery time objective, and the team really appreciates to know what this value is. So when it comes to actually implementing backup in a Kubernetes platform, you have two solutions. You either use something like a generic tool, such as Velero, that pretty much backs up all the Kubernetes resources and all the persistent volume claims of the applications. The positive thing about this is that, well, it's very generic, so your team only needs to learn one tool and you can trust that tool and you can, rehearse that tool a bit easier. The downside is that A, it might save too much data, and B, it might simply not work with some applications, for example, those that are not having a very stable file system image, right? Like some more complicated database solutions. So in that case, you might want to use application-specific backup solutions. This is what we're doing, for example, for backing up OpenSearch. Backing up the on-disk image of OpenSearch is containing way more data than needed, right? Because it does regular compaction, it does lazy compaction. So there are a lot of holes in the file system image of OpenSearch. Hence, it's better to use OpenSearch's application-specific backup to back it up. And I get very frequent questions like, okay, so what's the best place to store backups? And there I have a pretty strong opinion that unless you can prove me otherwise, use an S3 compatible object storage. The reason is that these systems are very reliable due to their lower complexity compared to file systems. They are cost effective. They're very easy to synchronize, for example, to offsite locations. And they're also very widely available. So they're available on any US cloud provider, on EU cloud providers, and even on-prem installations. And they also enable you to have quite cool techniques for protecting your backups so that, if somebody gets a hold of your production infrastructure, they cannot compromise your backups. And things you can do, for example, are using object lock or immutability. So in certain object, so you can, for example, say, don't allow anybody to change or delete this object from S3 object storage within the next 30 days. You can have also off-site replication, and you can even have off-cloud replication. And we, for example, use a combination of object lock and off-site replication to protect our backups. How do you conduct disaster recovery drills? Well, you first of all need to agree on a frequency, such as quarterly. You need to set some clear goals. So what do you actually want to achieve with these drills? And generally, you would want to make sure that the documentation is up to date and also to measure your recovery time objective. Who is part of that disaster recovery drills, knowing that it takes quite a lot of time and away from, let's say, more productive things of your team. So this could be, for example, half of the team every 3 months. That would mean that everybody gets 2 disaster recovery trainings a year. You then need to come up with a scenario, right? What is the environment states before the disaster and what exactly has happened, right? And then at the end of the disaster recovery drill, it's a good idea to leave some space for saying like, okay, so what went well, what went wrong, and to have some action items to improve on disaster recovery. So for example, during our drills, which we sometimes did in collaboration with the application team, we encountered issues such as it was not clear to the application team what is the scope of the backup. So they weren't sure, like, do you back up our Kubernetes resources or do we have to restore them? Do you back up this database? Do you back up that database? So a disaster recovery drill with the 2 teams was very beneficial to iron out these details. We had a few applications that were simply crashing after restore and needed a few manual steps to get them started. And this is great to discover during a drill, not so great to discover if you're actually restoring from a disaster. We also had some quirks, let's say. We discovered some quirks in how Valero works. So for example, it wasn't restoring the service account token in certain conditions, which meant that continuous delivery integration needed a small fix after restoration to make it work again. And then sometimes Valero also restored resources in what we perceive as the wrong order. So for example, we want all deployments to be covered by network policy, and we enforce this via policy as code. But then if deployments are restored before network policies, then to our Kubernetes cluster, it looks like somebody is trying to start a deployment without properly protecting it by network policies. And then we need to do some tweaking to make sure that restoration is done correctly. And then, to me, at least, the complete solution to finding all of these issues is just to go through a go-live checklist and, actually trying to cause a disaster and to figure out how to restore it. Last but not least, I would also like to talk about challenges when it comes to maintaining Kubernetes platforms. So, seems like we have a bit of a trouble as a species, to be very honest with you. We kind of tend to see maintenance as a complete waste of time. For example, the Genoa bridge, when it collapsed back in 2022, it was pretty much only at that time when people realized, oh, right, we also need to maintain bridges. We cannot just build new bridges or things like that. And you might hope that this is a problem only with civil engineers, but it seems like that's also an endemic in platform engineering. So for example, Datadog's container report in 2020 highlighted that the most popular Kubernetes version at that time had already reached end of life. So it didn't mean that it was vulnerable, and it meant that it was worse than vulnerable, because it didn't even get any security patches or any disclosures anymore. So we seem to also have a little bit of an issue in platform engineering when it comes to maintenance. So this is what I recommend on fostering good maintenance habits. So I would argue to first focus on cadence, make sure that it happens regularly, and do it manually. Then when you feel like, okay, now we have the cadence going, like let's focus then on predictability, right? So making sure that each of these maintenance operations are happening or as boring as possible, right? They don't cause any downtime. The application hasn't noticed that there's a maintenance doing, but still do it manually, right? And then when you feel that, okay, we really trust this process, we know how it's going, that's the right moment to automate the whole process. How do you do automation? Well, there are many good choices, but let me give you some kind of answers so you can get started. When it comes to the base operating system, so say Ubuntu 2020.04 and the Linux kernel and whatnot, you can either do in-place updates by installing a package called unattended upgrades, and then there is another project called QRD, which just looks at when the underlying operating system says, hey, I need to be restarted because I installed a new kernel. And then QRD carefully coordinates rebootal of the Kubernetes nodes to make sure that only one node reboots at a time, so as to make sure that, well, if all Kubernetes nodes reboot at the same time, you just get downtime, right? The other option is to just replace the nodes, right? So you're creating a new image. This is especially nice with immutable image. You create a new image, which is up to date. And then with something like cluster API, you just roll out the new image in your Kubernetes clusters. When it comes to system pods, we like to use Tecton, but Flux is apparently an equally good solution for this. And then for the application, we kind of appreciate Argo CD, but again, it's a very close container with the other two projects. We kind of prefer Argo CD because it has a nicer user interface, and our application developers really appreciate it. When it comes to continuous delivery, it makes sense to think about it in two ways. Like, do you want push-style continuous delivery or pull-style continuous delivery? And push-style pretty much means that, you know, when you do git commit, a CD is triggered, and that one does some kind of action like Helm upgrade -- install. And then what's different is that the action itself is kind of outside the Kubernetes cluster. And closer integrated to your source code repository. The other solution is to do something like pull-style continuous delivery, where you either have a webhook or you have a periodic trigger, and then there is something like Argo CD, which sits inside the Kubernetes cluster that just reconciles an application resource, right? So making sure that what you have put in Git is also what happens in Kubernetes. But at the end of the day, both solutions have, let's say, a bit of pros and cons when it comes to their security and convenience posture. At the end of the day, they both need to speak to the Kubernetes API to enforce a new state of the cluster. I was also asked, so what do you do about secrets? Because, well, you need to store them somewhere. So how do you reconcile secrets and putting everything in Git, right? And what I recommend is either to use a project called SOPs or GitCrypt. And these are decrypting the secrets in the CI/CD pipeline. If you want to make those secrets decrypt inside the Kubernetes cluster itself, then you, again, can use SOPs, or we really like the project called Bitnami Sealed Secrets, which allows the Kubernetes cluster to decrypt the secrets, but they essentially are not decrypted outside that Kubernetes cluster. And then you can also have external solutions such as HashiCorp's Vault or other key management systems, which are generally available with cloud providers. And we encountered quite a few maintenance issues as we started to catch up speed and do them more often. So, for example, we noticed that sometimes application developers were forgetting to put sufficient replication to application. So then if you were rebooting that one node where the application was located, then it was causing some downtime. The solution to this is either to set replication to, or if, for example, the application is stateful and there's too much investment needing to happen in order to make it stateless, well, then the solution would be, for example, to agree on a good maintenance window, right? When there are few users and application traffic is low. We also had issues with draining Kubernetes nodes taking too long, for example, because the application was not properly reacting to SIG-term signals or was not properly doing connection draining. And then we also encountered situations where it was not possible to drain a Kubernetes node, right? It was, our system would try to drain the node and make sure to move all pods away from that node before rebooting it. But there were, for example, badly written pod disruption budgets where you would say, well, I have 2 replicas and I want always 2 replicas to be up. So then Kubernetes just refuses to drain that node. And then we also had issues where, for example, well, to drain a node, you kind of need extra capacity in your cluster. So if you're always operating your clusters close to capacity, then again, you cannot drain them and you cannot rolling rotate them or rolling upgrade them as needed to do proper maintenance. So to sum up, set the scope to clarify what your platform team needs to deliver and what it is provided with. Make sure to foster the right alerting culture to ensure your team is aware, but not overwhelmed with symptoms which may lead to security and stability problems. And do practice disaster recovery to make sure that your team always has a way out and that even the worst incident can be recovered from. Thank you for your attention. Just let me know. I'm really curious to get your questions now. And just in case you have more questions, I'm happy to connect with you over LinkedIn. Thank you so much.
Yeah, I don't think there's any questions so far. One comment, I think, and I just agree with just about everything you said. The only thing I would say is that I think the best way to practice those incidents is on top of actually a live event that you elevate to a bigger one. Do you know what I mean? So basically, when you said you look at the P2s and the P3s, I think a really good way to practice the big ones is instead of waiting for that big one, right? Instead of waiting, almost like that disaster recovery you have there, right? But those P2s, what you can do is you can treat this as a P1, right? So you almost use this as a major disaster. You basically, you simulate these things. You use that as an example. Can I do that? Okay, I had a P2. Imagine it was worse. Or even try to solve that P2 with the same way they would solve a P1. And what you end up doing is you improve a lot of the things that would have gone wrong in that P1. That's
actually a very good point. So I just flew over it, but that's pretty much what we do with our go live checklist. So we have a certain checklist before we put all of our systems in production, where the sleep of the people are in jeopardy. And one of the things is actually we take down one Kubernetes node and see how do you react, right? So we're essentially triggering a fault to make sure that we're not having that discussion when people are depending on that application. And the second thing we do is that just because we need to regularly boot the Kubernetes nodes for security patching, that also ensures that, well, application developers don't take it for granted that uptime is going to happen, but rather they make the application tolerate node reboot, right?
Yeah, exactly. But you see, if you do that on top of P2, you almost have the best of both worlds, because you had already something that was a bit unexpected. You have something that already happened. You're going, okay, let's assume that we need to recycle the whole cluster, right? And then you almost say, we're doing it because of the P2, but you're really testing your P1. But it's easier to get the right focus. It's easier to get the right learnings because you're on top of something that is real. And you can also investigate much deeper. Why did that P2 ever occur? Because sometimes that P2 could have been something on the way to become a P1, right? Do you know what I mean? And I think the advantage of that is that you get a lot more focus, but you need to structure your security team and your business team to understand that that's what you're doing. Yeah. But the good news is that the more you do it, the easier it becomes to handle those P1s, because you have those practices. You almost use this to create the playbooks when you have some margin for error, like that one. You still have 3 days before the thing went south, right? And then it's interesting because you realize, holy shit, if we had 3 days, but it actually took us 2 days to be able to deal with it. So if you actually, it's almost like if we didn't have 3 days, then that would have been a massive problem because we would have not been able to do it within 2 or 3 days. You know what I mean?
I see that you're again coming back a bit to this topic you had at the beginning, like documentation culture, right? So, and this is what we also want people to do as part of an incident report. Like, okay, this incident happened. Like next time this happens, can we have some documentation to say, well, next time this happens, just type this command and it's going to be fine, right? And in many cases, people just they want to carry on and get something else. But it's very important to foster the right culture to make sure that, well, you're not in this alone. Like this particular thing could happen to the next person, or something similar could happen to you, and then you will be grateful to yourself. I mean, your future self will thank you that you took those extra hours on documenting why this is happening and how to recover.
Absolutely. But you see, the advantage of doing this on P3s and P2s is that, first of all, you start to get a practice of cleaning up your schedule. And you almost reward that creation of those playbooks. You can say, hey, so it's almost say, okay, you might not have time to create the playbooks at peacetime because you're always going to be doing this. You always have deadlines, you have this. But if that P3 occur and you can basically create the environment, then that's when you create the playbooks. You know what I mean? So it's a little thing, but it's almost using the incident strategically. So you use the P3s and the P2s as a way to prepare you for the P1s.
Exactly.
All right, so Michael is asking if you're going to share the presentation and the checklists, which I believe you are, right?
Oh yeah, fortunately the checklists are actually publicly available, so I'm very happy to share them with you.
Yeah. So send us the links. We'll put it on a page, right? That has the summit. So we had the video and the presentation. Send us the PDF or the Google Slides or presentations. If you send that to Alana, we can put it online.
I can send them to you afterwards, and the presentation is full of links in the strategic places, right? So I will send them also separately, but otherwise you can just click through. Yeah, here, for example, there is our Go Live checklist. You can then click through it and read through it at your own leisure yourself.
Brilliant, man. Okay, I think we're good. And no more questions. So thanks a lot, Cristian. And again, you guys are recurring presenter here at the summit. Always good to see you guys. Yeah. And I'll see you next time.
Thanks for having me, Denise. See you next time.